Okay. Bismillahirrahmanirrahim. This is my second lecture of a series of online recorded lectures. The first lecture was on vector integrals, and during first lecture we studied what are line integrals. I explained that, and then we have done an example on that. And I have already, when you were here, I have already given you a home assignment which was delivered on 20th of November, and it consists of two portions. First portion, no problem. In the second portion, from problem number 9 to 17, the material which we are now covering, it will cover last three lectures, that is 15, 16 and 17. Okay, now let's come for the today's business. We have surface integral. Now we have a vector A which is defined over the surface as ds is small portion of the surface, n is a unit vector drawn at ds, drawn at ds. ds is a small portion of the surface which is, this is covered with the black color, So I have written here is defined over the full surface as n is a unit normal to the surface at ds, which is a small area, and ds, it is a vector area which can be written as magnitude of ds into a unit normal drawn there. Then the surface integral can be written as a dot ds, and since it is a vector, we have written a dot n ds because ds is n ds. Now sometime for surface integral we use two integral symbol and write as, and sometime we use single symbol as here and write as, both have the same meaning. The examples of the surface integral are that you are integrating a scalar quantity over a vector surface S, and this is, since ds again it is n ds, so both are equal. This is different thing. Here phi is being integrated over a scalar surface S, and the last one, a vector A is integrated over the surface S, but since S is also a vector, A is a vector, so there is a cross between the two. So these are few examples of the surface integral. Now in order to explain the process, I am considering an example, and it says evaluate that integral of vector A is given. S is the part of the plane 2x plus 3y plus 6z is equal to 12, which is located in the first octant. You will be worried what first octant is. Now look, if you have a spherical surface, then you cut it in the middle, you will have a half semi-sphere up and half down. Then you cut in that plane, you will have 1/4, and then you cut in the third plane, you will have 1/8. So each one that small is known as one octant. That is known as one octant. Now in the figure, you see this is x, this is y, this is z. Everything here where x is positive, y is positive, z is positive, that is the first octant. The second octant will be with value of x negative, that is behind that, there. And the third one will be value of y negative, and that will be in this direction, and similarly down there, back there, in that direction, other one. So first octant is this one, second octant is there, then third octant is there, 4 is there, 5th is there, 6th is there, 7 is, and 8 is at the back. So this is how you can explain that what an octant is. Octant is mean 1/8 of a surface, okay? Now, let us draw first the surface, what this plane looks like. He says, and S is the part of the plane, this. Again, look at the figure and try to understand how I draw it. Equation is this. Now, when x is 0, y is 0, what is z equal to? It will be 6. So it means z can go up to 1, 2, 3, 4, 5, and that is 6. Now, when z is 0, y is 0, what is x equal to? When this is 0, this is 0, x is also equal to 6. So 1, 2, 3, 4, 5, 6, x is equal to 6. X exists, z exists. This is z is equal to 0. When x is 0, z is 0, y is equal to 3y is equal to 12, y will be equal to 4. So y is equal to 4. And what you should do, join this, join that, join that. That is the slanted surface. Look like this one here, okay? So this is a slanted surface, which is the plane, and its equation is given there. And we have to, this vector A is defined over this slanted surface, and its equation is that. I have shown you how to draw that surface. Now what we do, we take a small portion of this surface, and then out of that we take small ds. This is your ds. Okay, this is, and k is a vector which is parallel to z direction, unit vector. N is a vector which is perpendicular to this. Now see here. This is a slanted surface. Raji, camera ke? This is the slanted surface. Now, if this is the area, small area ds, then your k is there, but n is perpendicular to this. So there is an angle between n and k. There is an angle between n and k. Let's call that angle as theta. Okay, that is just symbol to denote it. Then we project this small surface down there in xy plane. Now here, this is the projection, and that is the region R, whose one side is dx and other side is dy, and its area is dx, dy is area of region R, of this region, okay, which is the projection of ds, okay. And we can write, now I don't need this thing. Now we come to the mathematical solution. I have described the geometry of the problem, that is how does it look like, and now we come to its mathematics. Now what we have to calculate is the integral, surface integral of vector A over the surface ds, and this can be written as or A dot n dx dy over n dot k, this is dot, and take its magnitude. Now let me explain how I got it. Actually, we were going to find the integral of ds over here, but we have projected ds down there, so your integral is now over the region R, that is here. It is also a surface integral. That was surface integral, but it was of the slanted surface, and this is the integral at the projection of the surface in xy plane where z is equal to 0. Now how I got this? Now please note, it is important. You know, one vector is k, other is ds. So k dot ds is equal to k dot n ds, and right, and that is equal to k dot n. It is ds cosine theta. You know how? Because dot product of two vectors is magnitude of k, which is unit vector, it is 1, magnitude of this unit vector, which is 1, cosine of angle theta between the two, and therefore it is just cosine theta. K dot n is cosine theta. So this whole thing is ds cosine theta, and that represents projection of, this represents projection of ds in xy plane, and from here ds is equal to, dx dy, because this is equal to that, divided by n dot k, that is take there, k dot ds, so this will give you ds. And this why for ds I have written that quantity. Okay, now things are not now difficult, they are simple. Now n is a unit vector perpendicular to the surface. N is a unit vector perpendicular to the surface at this point here, and therefore del of 2x plus 3y plus 6z minus 12 is a vector perpendicular to the surface. This is in fact gradient of this scalar quantity, that is the surface equation. So if you take gradient, and I have already described it when you were here in the live class, that this represents always a perpendicular to the surface. So this is a perpendicular to the surface, and a normal, it is normal, and unit normal in this direction will be del of this quantity 2x plus 3y plus 6z minus 12 divided by its magnitude, that is del of 2x plus 3y plus 6z minus 12 and only the magnitude. Now if you calculate this del phi, you can easily calculate it. I have shown you that in the second lecture. That will give you 2i plus 3j plus 6k, and its magnitude is square of 2 plus square of 3 plus square of 6 square root, and that is equal to 2i plus 3j plus 6k, 4 and 9, 13 and 30 over 7, because 49 square root is 7. Okay, so your answer is, this is the normal. This is the normal. Now you have to calculate n dot k. You have calculated n. Now you calculate n dot k. N dot k will be equal to 2i plus 3j plus 6k divided by 7 dot k. So I dot k is 0, j dot k is 0, k dot k is 1, and this is 6 here, so it is 6 by 7. So you have calculated this quantity. Answer is 6 by 7. Then you calculate a dot n. A is given to you and n is given to you. So take dot of this with a. Now if you take dot of a dot n will be equal to, therefore this integral reduces to r a dot n dx dy, and the value of n dot k, which is 6 by 7. Now you calculate a dot n. A is that one, 18zi, and this is 2i. So a dot n will be equal to 2 into 18 is 36 z, I dot I is 1. All right, then this is 3 into minus 12, j dot j is 1. It is minus 36 plus 6 k dot a, 18, k dot k is 1, so this is your a dot n, okay, which is scalar quantity, and hence this will be equal to or a dot n 36 z minus 36 plus 18, and this will be, inverted, 7 by 6 dx dy, 7 by 6, and what else? A dot n. Now, since we are working in region R, and therefore z is 0 there, and therefore this is R, and z is 0, and that is 7 by 6, 18 minus 36 dx dy, which is further equal to, because 18 is common, okay, when 18 is common, sorry, this is 36z, okay, so z is 0, okay, no problem. So 18 and 36 is minus 18 and 6, 3, so minus 21. Minus 21 dx dy. I'm sorry if I have done some mistake, you can just correct the figures there, okay. So it is minus 21 or dx dy. So you have integral in two things. So you can now solve it first for x, keeping y constant. So x will be solved from 0 to, x is from 0 to 6. Then solve it for y, that is from 0 to 4, and you will get the answer. Okay, so you complete it on your own, that is a kind of home assignment for you people to do. Okay, I'll take another one. I'll take another. This is second example. Second example is if example if f is equal to 2yi minus zj plus x square k and S is the surface of parabolic cylinder y square is equal to 8x in the first octant bounded by the planes which planes y is equal to 4 and z is equal to 6. Evaluate S f dot n ds. Okay, first of all, this problem is statement of the problem is up to here. Everything is given to you and you have to calculate that thing. How you calculate that thing? First, let's draw the figure. X, Y and Z. Y is equal to 4. First thing is that you are having a parabolic cylinder in the first octant, that is in that octant. Y is equal to 4 mean it cannot go beyond y is equal to 4 and it cannot go beyond z is equal to 6. So these are the boundaries of the parabolic cylinder which is situated in the first octant. Its equation is this. So see, when x is 0, y is 0. When x is 1, y will be square root of 8, maybe 2.7. Okay? When x is 1, this is, y is how much? 2.7. When x is 2, y is 4. Y is 4. When x is 2, y is equal to 4. So and then you cannot go beyond that. So that is that thing. Up there, that is that thing. And this is one. You see, that is surface is, from the origin it is going like this. Okay? So surface is, you can, if you have a big cylinder like a can of Dalda Banaspati, you just cut it. This is just the portion of that curved surface. Okay? It is like this coming from the origin. Okay, that is that one. How to, and then he says that f is defined over this surface. So what we do, behind that is which plane? Behind that there is a plane there which is x is equal to 0 plane. Okay, that is, so you consider a small portion of surface and then project it back there like before. But in the first example we projected it down there, now we projected the back. This is your ds and this is your region R, and you know what it is? It is dy dz. This portion is dy dz. In the last example it was dx dy, and now we have projected at the back. The remaining things you have to do like before. Okay, first you will find this is the equation of the surface, y square 8x. Now first of all you will find normal, and normal to the surface is equal to del of y square minus 8x. You will find that, and unit normal to the surface will be del of that y square minus 8x divided by del of y square minus 8x square root. This is how you will calculate, and answer of this, I haven't calculated it, I have left for you people to do it. You will find this del, this will be a vector quantity, that will be magnitude of this, and the answer is minus 4i plus yj divided by 16 plus y square. That is the value of n. And n is normal to this here, maybe that is in that direction, and I vector is in that, so that now you don't have to calculate n dot k, you will calculate n dot I, because your unit vector along x direction, it is perpendicular to this, is its I. So n dot I, you can calculate n dot I, and n dot I is equal to minus 4 over 16 plus y square square root. Again, this multiplication I have left to you, because you know I dot I is minus 4, I dot j is 0, so it is minus 4 of that. It is very easy to see. And then you will calculate f dot n ds. F dot n ds integral, surface integral, and that will be equal to region R. Region R is in plane x is equal to 0, and therefore it is f dot n dy dz over n dot I. Compare it again with the previous example. In first case, in that example, it was dx dy divided by n dot k, because your surface was projected in z is equal to 0 plane. Now it is projected in x is equal to 0 plane, and so that is the difference. If you have a surface, such a surface which is projected in y is equal to 0, then you will be having, you know, y is equal to 0, you will be having dx dz n dot j, n dot j. Okay, so if you project it there, then this expression will change, and you will have dx dz divided by n dot j. First example, we did it with dx dy divided by n dot k, because we projected in x is equal to 0 plane. Z is equal to 0 plane. In the second example, we have projected everything in x is equal to 0 plane, and you have dy dz over n dot I. If you project it there, then if you project it here, then okay. Now, I'm sorry for the break. What I was telling you, it is up to you, looking at the surface, where you can easily project it. Now, if your surface is like this is just another example. Okay, if your surface is like this, okay, coming from here and going there, then it is better to project it in this plane. And in that case, this expression will be dx dz divided by n dot j. Remaining, this will remain the same, f dot n, whatever is n, you will multiply with it. Now, if you solve this problem, then your answer will be 132, okay, because this is in the region R, f dot n. This is n, and that is your f. Okay, so you multiply n with this one scalarly, and you see what you get. Now, if I do all these things, putting that thing, everything, then I get the following: minus 1 over 4 minus 8y minus 4z minus yz dy dz. Now you can keep y fixed and integrate z from 0 to 6. Once that integral is done, then you integrate with respect to y, and then that integration will be y is equal to 0 to 4. 0 to 4. So you have two integration, first with respect to 0 to z, and then with respect to y. Doesn't matter. You can first integrate it from y from 0 to 4, and then z is equal to 0 to 6. Answer will be same, no problem. Okay, answer will be 132. 132 is the answer of that problem. Okay, please attempt it and then try to contact me if you have any problem. I can solve it and I can send you on the WhatsApp. Okay, you do have my number with you. Okay, that is one thing. Now the last one, that is volume integral. These we have discussed: line integral and the surface integral. Now we come to volume integral. It is a three-dimensional integral because volume is involved. So let's see what we have. So what see we have? Now if there is a closed surface which encloses volume V, if there is a closed surface, let me write first the volume integral. Volume integral. Now, if there is a closed surface, we have a closed surface which encloses volume, volume V. Then the example of volume integral are V A dV and V phi dV. Okay. Volume is a scalar quantity, so there is no vector sign on this. Surface is a vector quantity, it is area, so this is why I put vector sign on ds. no vector sign on that, that's scalar. Here vector A is defined over a volume V, and here a scalar function phi is defined over volume V. So this is integral of a scalar function over volume V, and this is integral of vector function over volume V. In this case answer will be a vector, in this case answer will be a scalar. Okay, so that is the thing. One thing more, there is an open surface and there can be a closed surface. Now if somebody asks you that what are the surfaces which are enclosing this volume, it has three surfaces, one here, one at the back, one here, one in opposite direction, one down there, one up there. There are six surfaces. So if you open a cube is a volume bounded by six surfaces. You can see those six surfaces. This, one in the back, two, this, one in the back, four up, one down, there are six surfaces. If you open all these, then it will not enclose volume V. If you cut it from here and you cut all these things, then this will be an open surface. Open surface does not enclose volume V. Okay? So that is, the volume is always enclosed by a closed surface. Okay? Closed surface as not an open surface. Then example. Evaluate V 2x plus y dV where V is a closed region, that is volume bounded by the cylinder cylinder, cylinder, z is equal to 4 minus x square, and the planes x is equal to 0, y is equal to 0, y is equal to 2, or z is equal to 0. So first of all, let's see how we can form that volume. Okay? Again, coordinate system x, y and z. Look at the planes. X is equal to 0 is this plane. Y is equal to 0 is this plane. Z is equal to 0 is this plane. So it means that region is in first octant, okay? And y is equal to 2. So it is 1 and 2. And the equation of the cylinder is z is equal to 4 minus x square. Put x is equal to 0. How much will be? Z is equal to 4. 1, 2, 3, 4. Okay? X is equal to 0, z is equal to 4. X is equal to 1, z is equal to, x is equal to 1, y is equal to, z is equal to 3. Okay? When it says x is equal to 2, z will be equal to, sorry, I am going in this direction, actually I should be that. Okay? X is equal to 0, z is equal to 4, x is equal to 1, z is equal to 3, x is equal to 2, z is equal to 0. So that is the curve, and you will just complete this. That is the cylinder, which is, it is not going down there, that is, it is not beyond z is equal to 0, is there, it is not beyond y is equal to 0, it is not beyond y is equal to 2, it is not beyond y is equal to x is equal to 0. So that is the cylinder, a portion of the cylinder, and so this is y is equal to 2 plane, that is x is equal to 0 plane, that is y is equal to 0 plane, and that is z is equal to 0 plane. All these three planes I have shown in the figure, and he says evaluate this integral. Okay, so that is simple. We are having three integration v, 2x plus y dv. We are integrating a scalar quantity over volume v, and that is equal to 2x plus y dz dx dy x y z Now let me explain. There is some point to explain here. I am calculating it. There are three integrals involved, one along y-axis, x-axis, one along y-axis, and the third one along z-axis. There is a functional relationship between x and z only. There is no functional relationship between x and y or z and y. Okay? So it means that value of z depends upon value of x. So value of z is going from z is equal to 0 to this value. So whatever value x takes, value of z will change until it reaches to its maximum z is equal to 4. So this is why this integral is from 0 to 4 minus x square. The remaining thing is integrate it first with respect to z between these two limits, and these two integrals are left. So answer will be 2xz plus yz, and limit will be z is equal to 0 to z is equal to 4 minus x square dx dy. Put this only for z because it was integrated over z. So xy, and inside you will be having 2x 4 minus x square plus y into 4 minus x square, right? This is upper limit. Lower limit is z is equal to 0, z is equal to so minus 0, no problem, dx dy. Simplify this. Simplify this, what you have, x, y, it is 8x minus 2x cube plus 4y minus x square y, and dx dy. Now, there is no functional relationship between x and y, so it doesn't matter whether you integrate first over y or x. So let's integrate over y, and y is ranging from 0 to 2. 0 to 2, 0 to 2. So you integrate it with respect to y, and you will be getting 8xy minus 2x cube y plus 4y square over 2 minus x square y square over 2 and then dx. Limit will be from 0 to 2 and these limits are for y only. You put the value of 2 there and then you will be having remaining thing only for x. Then if you calculate all these things, then what you will have, the answer will be 80 over 3. If you put these values, then everything will be, integrated over x. Then the value of x will range from 0 to, see here, 0 to 2. So 0 to 2. And if you integrate all that, this is simple integration you must have learned in FSC. So answer will be 80 over 3. You complete that problem. Okay, I am going to stop here. And next time we are going to talk about two important theorems, the Gauss's divergence theorem and Stokes theorem. And then I'll give you another set of assignment which will be an official one because there is an official requirement from the university and you have to solve it. Okay, thank you very much. Any problem, you have my phone number, you can just give me WhatsApp message, just give a picture of what you have done, I'll correct it, I'll tell you. Thank you very much.